Okay, hello everybody. My name is Emil. Today's presentation is going to be about reverse engineering tactics and how we can build an application in C# and analyze a file's digital signature and use this information so that we can potentially identify malicious elements in the computer. This presentation was developed in accordance with Florida International University, specifically the Computer Engineering Graduate Program. This class is overseen by Dr. Faisal Kaleem. So any of the things that you'll see in this video should only be used for educational purposes. With that said, let's go ahead and continue on with the presentation. So again, just to reiterate, we are going to take a look at reverse engineering tactics so that we could identify, the ultimate goal is to identify malware. We're going to do this by creating a tool in C#, and this tool is basically a static analysis of the malware. And what this tool will end up doing is computing specifically the MD5 hash of a file, storing that hash, and then basically when we go ahead and update this file, we can compute the hash again and we should see a difference. So moving on, everybody should be on the same page in terms of the topic or the definition of reverse engineering. And the purpose of reverse engineering is to dissect and decompose a finished product, a published product, and once this decomposition has been done, to analyze the functionalities and work your way backwards pretty much. Okay? Now, in order to identify malicious files or malicious elements, what we do is to acknowledge the digital signature of a file, basically. After acknowledging this digital signature, usually when a malware comes in, let's say for instance, kind of like a rootkit, so you have some DLLs and some executables in the system32. Let's say, for example, notepad.exe. So something like a rootkit would overwrite those DLLs. You would have the same file names, but when it comes time to open that application, thereby executing that notepad.exe, you actually instigate and you run the malicious file. So this could be a virus, this could be a worm, etc. So these are malicious files hiding and disguising themselves as core executables or core DLLs. With this in mind, how can we determine if a file has changed or not? So every file has a digital signature, and we can see this digital signature by computing the MD5 hash. So let's see how this application looks like. Let's take a look here. So what I'm going to do is show you an example of how we can compute the hash of a file using a utility called MD5D. Okay, so this is a tool that you can go ahead and download online. It's free, and basically the interface for this is through the command prompt. Okay, so what I'm going to do is just give you an idea of what the hash looks like and how we can do this through the command prompt. MD5D 64exe. The parameter that I'm going to pass to it is going to be C, Windows, System32, Notepad.exe. So what you see here, 5A, 18F, etc., CF11, This is the digital signature for notepad.exe. Um, I can go ahead and compute the hash for all of the files located in this directory. And what I would do is keep track of them. And in the event that I suspect that the machine has been infected, I can go ahead and recompute the hash for the files and basically do a compare and contrast. So what we're going to do is take this tool and take it a step further, and basically we're going to create our own interface. So with the same concept in mind, I'm going to go ahead and show you the application right now. Okay, so here is the application, and again, the reason for this application is so that we can have a nice graphical user interface. It's much easier to work with than with the command line. And what this application will do is either target a directory or a file. If it's a directory, it's going to iterate through all of the files within that directory, compute the hash for them, and store them within a local database. So a perfect example, what I've done here is I've created a copy of a dummy system 32. Okay, so let's take this tool and let's point it to the dummy system 32. And what I'm going to go ahead and do is tell the utility to scan all of the files. I'm going to go ahead and move one of my C programs in this directory, recompile it, and basically overwrite some DLLs in here. We're going to rescan this directory, and we're going to see if the utility picks up this change. Okay. So no potential threats. Again, this is just the first recording of these files. So let's say a malicious software comes in. So this is actually a very simple virus. Basically what this virus would do is eat your hard drive until it's full, until the system becomes unbearably slow. But overwrite this console.dll. So let's go ahead and compile this. Let's go ahead and run that executable, overwrite the console.dll, then run our scanner and see if it picks it up again. Really audacious command line, and then finally saying I love you, it should have overwritten this console DLL. So now I'm going to go ahead and go back to my utility. I'm still pointing to the same directory. Let's rescan it. Okay, so the signature of this file has been modified. This tool gives us three options. Approve just updates the database right now, because right now the database is saying that for this file, for this hash, my status is under review. If I click on approve, basically it's just going to go ahead and ignore it. If I go ahead and click on flag, basically it's going to keep this status as under review. I can go back to it later. At least I have a history of what file is potentially infected. If I know for sure that it is a malicious file, I can go ahead and simply say, hey, listen, I'm sure, and delete it. And then it's going to go ahead and continue scanning. Okay, so that's basically how the application works. Now, let's go ahead and take a look at how we did it. So, in order to understand this, some basic knowledge in C# and SQL is assumed here. Okay, so let's start out with the main form. What I've done is I've laid out some controls here, text box controls to hold the path of a directory or a file. This text box control basically spits out the MD5 hash. So I didn't show you this one, but let's say, for example, if I didn't want to scan a directory, I wanted to scan a file. On the on-check change event of this radio button, when I go ahead and click on File, I'm going to go ahead and set this label to visible as well as this text box to visible. I'm going to go ahead and browse. Notice that the modal dialog that shows up here is specific for a file, as opposed to when I switch it back to directory, this modal dialog is specific for selecting a folder. Okay. Let's go to a file. Let's just select any file. I'm going to go ahead and compute the hash. And basically we spit out the hash in this text box. You also notice that while it's scanning, I'm displaying here kind of like a log, which is basically the file name along with its hash. So I guess the most important thing first is to take a look at the class to compute the MD5 hash. Let me go ahead and go here. This is a class that I created. It's called MD5 helper. Okay, so this class basically contains two methods. One is called sync file hash, which basically accepts a directory, and it's going to iterate through that directory and look for the files, compute the hash, and basically store them in the database. Okay, so before we go into there, the main thing that we want to see is the compute the hash. Okay, so I've created a function here called get hash. Okay, and what this is accepting is basically the path to your file. Okay, you need to use a file stream, and you will need to use the MD5 crypto service provider. Okay, so with the crypto service provider, you can actually say object.compute hash, and basically all you need to do is give it the file stream. Okay, so it's pretty much done for you already. Once you get the hash, you're going to go ahead and replace some of the characters and remove the dash characters, and then what you have is basically the hash that we've seen all along. So in the event of the file, when I go ahead and click on scan, basically what I'm doing is calling that function get hash, taking the return of that and plugging it into this text box control. Okay, so now that we've seen how we can compute a hash of a single file, let's go ahead and revisit the event of when we go ahead and scan a directory and basically loop over the files within that directory. Recall that what this is actually doing is taking the hash and the file name, storing it into a database. That way, if it was to scan that file name again, and if there's a different hash, basically prompt the user to give some sort of action. So in the event that I go ahead and browse to a directory of my choice on the on-click event of scan, what I'm doing is calling this function called sync file hash. Okay, so the important parameters to acknowledge is the directory. Okay, the rest of the parameters here is actually just for cosmetic purposes, not necessarily for logical purposes. So for example, when we went ahead and scanned the directory, we saw some activity here in these controls. A log was being written and the progress bar was incrementing. Okay, the reason why I'm passing it here is so that I can append text to it. Same way with the progress bar. The only reason why we're passing the progress bar to the sync file hash function is so that we can increment the value and we can see some sort of visual indication that something is happening behind the scenes. Okay, so the main important one here is the directory. From a functional standpoint, we are passing a SQL Compact Edition connection object. The reason for this is so that we can query the database. We can go ahead and insert and update to whatever tables that we needed. The data model is not very complex. It's actually a single table with 3 columns. So before I show you the data model for this, let's go ahead and take a look at what the sync file hash function is doing. Again, let's try to not really pay attention too much about the progress bar and the the log controls. Here you'll see something like if my rich text box control for the log is not null, then I'm going to go ahead and append some sort of text to it. Again, this is just for cosmetic purposes and a visual indication to the user that something is happening behind the scenes. The real thing that we want to take a look at is how we are storing the hashes, how we are comparing them, how we're computing them. So here I grab my directory. In order to use this directory, I have to import system.io, if I'm not mistaken. So basically, when I say directory get files, I pass the directory, I get an array of files. Okay, so this is the full path to the file. So this is something like C Windows System 32 notepad.exe, C Windows System 32, let's say star.dll. Okay. Again, let's ignore this part here. Let's ignore the progress bar. Again, this is just for cosmetics. Okay. This part here is basically 2D file hash. I believe this is just for the return value. This holds no logical purpose. It's just so that I can return a bidimensional array to whoever's calling it, so that it's a little bit more convenient. Okay. Now, the next thing that we need to do is iterate through the files in the directory. Okay. Since we're going to go ahead and be running some SQL commands, that object that I passed for SQL Compact Edition connection object, I'm going to go ahead and open this connection. So I'm now entering the loop. I'm looping through n files that I've detected. Okay. So what I'm going to do first is look in my table for any records, any matching records for that file name. If I don't find anything in my table, then I'm going to go ahead and insert it into that table. Once I have inserted into my table, I don't actually need to go on with the rest of the logic, so I'm just going to go ahead and loop after that. If I do find something, I am grabbing the hash from my database or from my table for that specific file name. Once I get the hash that was stored in the table, I'm going to compare that hash with the new computed hash. If they're equal, I'm just going to go ahead and continue. If they're not equal, then we need the user to do something about it. We need to prompt them. So what I've done is I've created another form called acknowledge file. This is an instance of that form, and this is the pop-up that you saw that said, hey, listen, this file has changed. Do you want to approve it, delete it, or do some other action with it? But what you do here is you create an instance of acknowledge file, you say show dialog, and then this waits for a user's response. Okay, so let's go ahead and take a look at acknowledge file. Here's the design. So flag was the other one. Okay. Now, what do we want to do? Approve, which is basically ignore it. Do we want to say delete, which means remove it from our table and delete it from disk? The next thing is flag, which means don't delete it from disk, but update our row in the database to a status of something like under review. Let's go ahead and take a look at the on-click event of the approve button, and basically we're saying update signatures set hash. So if I had a different hash, if it detected a different hash, since I approved it, and let's say this is something like an update you did or the user did an update to a file, he knows that the update to that file is not malicious. Let's just go ahead and update the hash. So we're going to say update signature set hash equal to my new hash, where file name equals that file name. Okay. Going back here, delete. This is pretty simple. All we're doing here is just confirming that the user really wants to delete. Delete it from our table, so delete from signatures where file name equals file. And then afterwards we're going to say file.delete and then our full path to that file. Flag, something similar. We just want to keep track of it in our database. So we're going to say update signature set status to under review for that file name. Okay. And then this.close, after clicking on either approve, flag, or delete, this.close just means that it's closing that form, and once it closes that form, it returns us to our MD5 helper here. So just to reiterate, if I never recorded that file before, I'm going to go ahead and insert that file along with its hash value and status of approved into that table. Okay. If that file has been recorded before, meaning count is greater than 0, okay, I'm going to grab the hash that I've stored previously. I'm going to compare it with my new hash. If my new hash and my previous hash is identical, then I'm just going to go ahead and ignore it. If for some reason they are not identical, meaning that the file has changed, then what I'm going to go ahead and do is basically show a dialog such that the user can interact, and what he needs to do is basically decide whether he wants to delete, flag, or approve that file. Now, we talked about the data model. Obviously, you saw that the SQL statements are very, very simple actually. And if you notice that the SQL statements are only dealing with one table, our table is called signatures. And if you notice that the amount of columns that we're only dealing with is just 3 columns. So let's take a look at our data model. Okay, so the columns that I have here is just file name, hash, and status. Okay, this is what it looks like when it's stored. Again, file name will contain the full path to that file name. So C users, email C, desktop, appendpassword.txt. For that file, that is the hash that I have. That's pretty much it. So when we compare the functionality of the application that we built versus running it from a command line, obviously this is much more convenient to use a graphical interface. This was a high-level architectural overview of how we can create our own application to help us identify files that could potentially be malicious. The main topic of this was this part right here, how we can keep track of our previous hashes and compare them after some files have been updated. And then of course the other big one is actually computing the hash of a file. Okay, so with that said, that pretty much concludes this presentation of how we can build and how we can create our own application to simply give us the digital signature of a file. If you'd like, I'd be more than happy to send you guys the source code. If you can shoot me an email at ecob, as in boy, A001 @fiu.edu. Once again, this is Emil, and thank you for watching.